Okay guys, we're gonna start this unit of technical drawing talking a little bit about scales, okay? You already used scales in other subjects, for example in geography, but we need them as well in technology. It's a very easy concept to understand. So in technology we had to draw many objects. For example, when you had to draw an aircraft, you had to fit it to the size of the paper, right? This is quite obvious. So imagine that you have this aircraft, and the real size is something like 70 or 80 meters long. So obviously to draw it in a paper you have to reduce the size. So this is what we call scaling down an object. Okay, so therefore the definition of a scale is the relationship between the size of the drawing and the actual or the real size of the object. So the scale is the drawing size. We have to measure the size in our paper. We divide it by the real life size, and then we get the scale. So for example, you have this dinosaur, and the scale is the drawing size and the real size. You get the scale. We have many different examples. In geography, as I told you, you use scaling down. It means that you have to reduce the size of the object. Obviously, in a map, to draw it in a paper, you have to reduce it. For example, 1 to 100,000 means that you have to reduce the size by 100,000 times. Or on the other hand, it means that every centimeter, for example, in a map, means it's equivalent to 100,000 centimeter in a in the real size. Okay, we have on the other side we have a scaling up. Imagine that you have to draw a very small object and you have to fit it in a paper. So in this case, what you have to do is increase the size. Imagine a virus that or a very small part. So you write the scale on the other way. You write down the bigger number on the left side. In this case is 50,000 to 1. It means that you have to increase the size by 50,000 times to fit it in the paper. Okay, scaling down for big objects, scaling up for is very small object. And finally, when you have to draw an average object, for example a pencil, we use what we call full scale. Full scale means 1:1, that you are drawing the object using the real dimensions. Okay, so there are three types of calculations in this case. The example number one is when you have to work out, for example, the drawing size. Imagine that you have a real object. In this case, we have the dinosaur, and we know that this is a T-Rex, and is 15 meters long. And they tell us that we have to use a reduction scale of 1 to 200. So it means that we have to reduce this size 200 times to get the drawing size, to know how long the dinosaur is going to be in our paper. Okay, so the first thing we have to do is write down the formula. The scale, we know that is 1 divided by 200, no dimensions. Remember that the scale has no dimensions because we have the same dimension up and down, and this is equal to the drawing size divided by the real size. So we only have to replace the numbers we have, 1 to 200, and this is the incognita. This is what we had to find out. The drawing size divided by the real size, that we know is 15 meters. So we cross the numbers, as you know how to solve this, and then dividing 15 by 200 means that the drawing size is going to be 0.075 meter. Be careful with the units, okay? So when you go to your paper, you have to draw a dinosaur 7.5 centimeter long. Okay. Another type of problem is when we have to calculate the other way around, the real size. Imagine that you have this drawing in your paper. You have a dinosaur which is the 80 centimeter long, and again we have on a scale of 1 to 200. So it means that the real size will be 200 bigger. Okay, so obviously multiplying 200 by 8 centimeter, we get the final size. But again, by using the formula, in mind that you have no common sense, you don't use your common sense, just by writing the formula, you can always solve the problem. So replacing the numbers, we have the scale that is 1 divided by 200 is 8 centimeter divided by the real size, that this time is the incognita. So we cross the numbers again, and the result is 1.600 centimeter, or 16 meter. Finally, last type of problems, when we have the information of the real size and the drawing size, and we have to work out the scale. In this case, we had to be careful with the units. Okay, we had to use same units up and down. So we write down the drawing size, which is 10 centimeter, the real size 12 meter, but we cannot divide this because we have different units. So first thing we have to do is transform one of them. For example, we can transform, in this case it's easier transforming the meters into centimeters. So we have 10 divided by 1200 centimeter. That give us 1 to 120. So in this case, the drawing has been drawn using a scale of 1 to 120. What is the same? We are reducing 120 times the drawing, the real size, to fit it in our paper. Okay, so now you're ready to solve different problems. Bye bye.